Hello, my name is Bradley Eichelberger, and I am the PIPAP GIS Specialist Consultant for SPREP. This is the third and final video that serves as supplemental material to complement the training on the Pacific Islands Protected Area Portal and Geographic Information Systems for Improved Protected Area Planning and Management workshop that was conducted in the year 2020. In this video, we will focus on importing GPS data into QGIS and then use field-collected point data to map a polygon boundary. As mentioned in the video introduction, we will be using GPS points that were collected in the field to map a polygon boundary. The specific points that we will be using were collected during the field exercise for the Samoa workshop. We used Garmin GPS devices to collect waypoints in order to map the property boundary of the Tate building in downtown Apia, Samoa. We collected data in two different ways. First, we averaged point locations and stored them as waypoints on our GPS device. These were later exported out as GPX files. And secondly, we recorded the coordinates from the GPS device onto a piece of paper and later transcribed it into a CSV file using Microsoft Excel. We can open the CSV file or comma separated value file in Excel and examine the data. So if I navigate to the folder where the data is stored and open it up, we can see there are 4 fields. I have an ID field, which gives a unique identifier for each one of the waypoints. There is a X-coord field, which contains the X coordinate recorded from the GPS device, and that is stored in UTM format, so those are represented in meters. We also have a Y-coord field, which contains the Y coordinate, again, stored in UTM format. There's also a notes field, which contains descriptive information to help in the identification of each one of the waypoints. It is also extremely important to remember which coordinate system that these coordinates were collected in. In this case, it was UTM Zone 2S. Without this information, we would not be able to locate these coordinates. You can make your own CSV file by recording such information in Excel and going up and saving it. And instead of saving it as an Excel file, you want to make sure that you're going to save it as a CSV, delimited file, and then select Save. In this case, we're going to overwrite our file. And Excel will always ask you if you want to keep this format, and you will say yes. In my folder, I also have this Tate building GPX file. Next, I will show you how to load both of these file formats into QGIS. In QGIS, we can load the tabular data or the CSV file using this Add Delimited Text Layer tool. And when I select it, it opens up a dialog box that lets me navigate to where the CSV file is stored. I open the file, and there's a couple options here that we need to be aware of. The first one is the file format. As I mentioned before, it's a CSV, so we have CSV selected. We also have the geometry definition. These are point coordinates. We have to make sure that the X and Y fields correlate to where the X and Y coordinates are stored in the CSV file. As I mentioned before, it's extremely important to know the coordinate reference system. In this case, I want to make sure that it is WGS 84 UTM Zone 2S, which is the coordinate system that the data was collected in. And we can also see QGIS loads a sample of the data, and we can see that it matches our CSV file. So we're just going to go ahead and click Add, and then Close. And our point coordinates are now loaded into QGIS. To give some reference for the points, I'm actually going to add a raster layer. In this case, I'm going to add some Sentinel-2 satellite imagery for Samoa. So I'm going to navigate to the Samoa Sentinel-2 TIFF file, click Open, Add, and Close. Now that the imagery is added to QGIS, I'm going to bring the sample GPS points on top and then change the symbology to red to make it stick out against the background imagery. And since the imagery is rather coarse, I'm actually going to zoom out a little bit. And I can see my points displayed on top of the satellite imagery outlining a portion of the Tate building. I can also add in a GPX file the same way we would add in a vector file. If I go to Add Vector and navigate to where my GPX file is stored, in this case it's called Tate Building GPX. I select it, click Open, and then select Add. QGIS is going to ask which vector layers do we want to add from the GPX file. And there's 5 options. GPX files store 3 types of point data and 2 types of line data. Our options are route points, routes, track points, tracks, or waypoints. We collected the point data as waypoints, and you can see this in the GPX file if we look at the number of features. The number of features are all 0 for everything except for waypoints. So this will help us decide what to bring in, and in this case I want to bring in the waypoints, so I select that and hit OK and then close. And that is how you add point coordinates in from your GPX file. In the next step, we are going to create an empty polygon shapefile and then use the points that we just loaded in to draw a polygon boundary. To do this, we'll go to the Layer tab in the menu options and select Create Layer and New Shapefile Layer. The first parameter is the file name. I'm going to name the shapefile Tate Building Polygon. And select Save. Another key parameter is the geometry type. And since this is going to be a polygon, we are going to set that to polygon. We also need to identify the coordinate reference system. And as I mentioned before, we were using WGS UTM Zone 2S. So we'll select that. And then we can also add fields to the attribute table. In this case, I want to store the name of the feature as well as the type. So the first field I'm going to record is actually a name field. So I'll write in name. It will store text data, and we'll use the default length of 80 characters, and click Add to Fields List. And now we have a name field for the attribute table. As I mentioned before, the second field will be called Type. Again, this will be used to store text data, and I'll use the default length of 80 characters, and I will add this to the fields list. And now we have 3 fields in the attribute table. An ID field that QGIS automatically adds, the name field, and the type field. Next, we will click OK. And now we have just created an empty polygon shapefile. I can toggle editing the shapefile by going up and selecting this pencil. To toggle the editing, I want to make sure that I have the layer that I want to edit highlighted. So make sure Tate Building Polygon is highlighted, and then select toggle editing. And now I'm presented with some tools that'll help me create a polygon. But there's one extra step that I want to add. I want to add a snapping toolbar. And as you might recall from the workshop, the snapping toolbar is useful because it lets us actually snap or grab onto the actual point and use that to help us trace the vertices for the polygon. So I'm going to right click on an empty spot in the toolbar section of QGIS and then check snapping toolbar. And once I click on this magnet for the snapping toolbar, we start enable snapping. So now, as I'm drawing the polygon boundary, it will let me actually grab the point to be used as a vertex as I trace the polygon boundary. So I'm going to go and select the Add Polygon feature. And now as I move the cursor close to any of the GPS points, it kind of grabs onto that GPS point, and I can click to start tracing the polygon boundary. Once I've selected all the GPS points, I right click and I can add the attributes for the new polygon. So in this case, I'm just going to give a generic number of 1 for the ID. I'm going to call it the Tate Building for the name field. And then for type, I'm just going to call it building. And then click OK. And now I have successfully added a polygon boundary using points that were collected in the field from a GPS unit. And the real-world application of this module would be if you were to go out and collect point locations along the boundary of a protected area. You could come back to the office, open QGIS, and accurately map the boundary and submit it as a polygon shapefile. This concludes the series of tutorials that were designed as supplementary videos for the PIPAP and GIS workshop of 2020. I hope that you found them as a useful resource, and I look forward to working with you again. Thank you.